So, hi everyone, this is Lydia. I'm here again to explain problem number 3 of the real midterm. So, for this question on acid and bases, this kind of question is the one that I really don't like, but I had to do it because, yeah, I'm taking organic chemistry, so I really need to do it. Just like you guys. So let's just jump right into it. So for this one, you can see I circled one H right here, which means this is the acid, because it's the hydrogen donor, the proton donor, which makes it an acid. And so if this is an acid, which means this will be the base. And the conjugate acid will be the conjugate, will be this one. And this one would be this one. So we just need to take out, add and, okay, there's no this one. So basically here we have this as an acid, and for the base we will have the one without the proton. So if we have this, we will have to make sure that the formal charge is correct. So in this case, for oxygen, we have to make it a complete octet, we have to add 2 more electron pairs, which then makes the formal charge of oxygen positive. Why? Because the group number of, let's just jump right into here, and oxygen is right here, is group 16. So if it's group 16, it would be like 6 minus, there are 2 bonds, 1 here. So 2 minus 1, 2, 3, 4, minus 4 equals to 0. Oh yeah, it's 0. So there's no formal charge right here. My bad. It was from, the formal charge is probably right here somewhere. Oh yeah, here. So I probably miscalculated it. Okay, so the formal charge right here would be, for oxygen, would be 0. And for this one, we have to calculate the formal charge for oxygen as well, but we have to complete the octet. So we have 1, 2, 3, 4, 5, 6. Okay, so it's 6, so it's 0 formal charge. And for the sulfur right here, we have to complete octet once again, and it will be sulfur. For sulfur, let me just take a look. It's group 16 as well, so we have 6 minus, this is for sulfur, this is for oxygen, don't misunderstand it. So this is 6 minus bond number, which is 1, minus 1, 2, 3, 4, 5, 6, minus 6, which is -1, which makes the formal charge -1. To compare the strength of the acid, conjugate acid and bases, we have to see whether that is stable or not. And in this case, it's pretty stable, which makes the conjugate acid to be weak. This is stable, so it's weak. And for the base, it's also stable, so it's weak as well. Because the hydrogen right here likes to dissociate and likes to give its hydrogen, like the proton, to here. because just to make the oxygen right here comes to a neutral formal charge, like 0 formal charge. And on to the next question. We have this molecule right here. And again, the circled proton likes to give the molecule its proton. So yeah, so if this is which makes it an acid, and this will be the base. So therefore, the first one is acid, right? So it will have the conjugate base, which is just right here, and this will be the acid. If added one what's it called? Proton. So let's just draw the weird thing right here, and H. Let me just make it a dot, like 2 bonds of H and H. And here we have 2 fluoride, yeah. And for the base, we just need to take out one, again, the weird kind of guy looking thing. So we just need to take out one hydrogen. We'll make it negative. So to complete the octet, always check for the octet. The nitrogen here, we need 1 lone pair to make it a full octet. And otherwise, all the molecules seems good to me. And we have to check the formal charge next. So the nitrogen here, basically, we have just to check the nitrogen's formal charge. So it's group, let me just take a look. Nitrogen is group 15, which means 5. So we have, where do I write? Okay, I can write here. Nitrogen, the formal charge is 5 minus 4 bonds, minus 0, which is plus 1. So here we have a plus sign. And for here, the right-hand side one, we have the nitrogen is equal to 5 minus 3 minus 2, which is 0. So there's no formal charge on top of it. You can as well check for the fluorine right here. And if you check for that, let's see what's the group number of fluorine. And it's group 17, so we just need the 7 right there. So fluorine, need the 7, and we have to complete the octet. Always remember, I just had it in my head, so might as well write it down. It will be more clear. So if we 7 minus 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7 minus 7 is equals to 0. Yes, so same thing for the fluorine. This works on both fluorine, so the formal charge of the fluorine is 0. And to see whether it's a strong or weak acid or a strong or weak base, we have to see whether the molecule is more stable or not. So in this case, since this is more stable, like the molecule right here is more stable, it will be a weak acid in this case, weak acid. because we just know that is an acid. So if it's more stable, it will be weaker. So if this is weaker, that will make the conjugate base of it stronger. So it's strong. And the same thing applies to the acid right here. If it's the base of the original is more stable, that will make it a weak base. So which means the acid right here is stronger, because the conjugate acid is stronger because the original where it came from is more stable, which is a weaker base, which then leads to the conjugate acid to be stronger. Okay, so next one we have the chicken feet looking thing. So you can see there's as well an proton right here, hydrogen right here, which makes it an acid. And if that is an acid, this will be the base. So if that's the base, it will have a conjugate acid, and this acid will have a conjugate base. So in this case, we have to write it down if just add a proton right there, and rewrite the chicken feet O, and chicken feet F, fluorine. And yeah, so from now here we have to check for the check for the lone pairs and the formal charge, just to make it nice and clear. Let me just rewrite it all right here. It's too ugly looking. Okay, so from the acid, conjugate acid right here, we will check for the lone pairs. For C, like carbon, we don't have any lone pairs needed because we have like 1, 2, 3, and 4 right here. So we don't need a lone pair because it has a complete octet. And for fluorine, yeah, it's in the end we just calculated right here. So if it's like the terminal fluorine, it's mostly complete octet. So we just need to check for the oxygen right here to see whether there's a octet or not. So since there's only one bond right here, so we have to add like 6 electrons to make it an octet. And to check for the formal charge of the oxygen, the oxygen has its group 16, which is, we only use the 6, and minus the bond number, which is 1, and the electron numbers, which is 6, and we have a -1. So here we have a negative formal charge. And to see whether if it's strong or weak, this will be we have to check for the strength. Yeah, okay, so this one will be a weak acid because it's less stable. Oh wait, it's more stable, pardon me. It's more stable, so it's weaker. A weaker conjugate acid because it's, let me just write it down, more stable. Less stable. So if this is more stable, it will be a weaker acid. And the same thing applies to the base. If it's more stable, it will be a weaker base. So, and that wraps up the 3A and B. So continue to 3C. Okay, so 3C we have, let me just highlight the thing, E. Okay, so A, B, C, D, and E. So if we would like to compare the strength of the hydrogens, we have to look for the electronegativity, and the second one is the distance, and the third one is I remember it was the bond it's connected to. Let me just take a peek at the notes right here. We can't do that during the midterm, but we can here because I'm trying to explain. Okay, number of these atoms and the distance to the charge. Okay, so we have the electronegativity and we have the distance, so we just need the number of these atoms. Like how many atoms are like the numbers. So for instance, if it's connected to a bunch of atoms, like we have right here, like it's connected to 3 instead of 1, it will be a stronger acid, right? So number does matter. So back to here. First, we have to find so obviously we can notice that because this is basically like the longest, which makes the the strength of the hydrogen D to be the least. So we have to place it here, and we can see. So the bonds right here, they're definitely weaker than the single bond right here. So we just put it, it's either they're either this one or this one. So we can compare the single bond first. As you can see, oxygen is more electronegative than sulfur, which means it's hard for it to donate the proton because it's more like electronegative, so it tends to pulls the proton into itself, which makes it hard to donate. Like oxygen doesn't like protons to leave itself, so it's hard for it to donate the thing, which makes C hydrogen less acidic than B hydrogen. So we have our ranks here, and in terms of the double and triple bonds right here, because let me just highlight it. The double bond, as you can see here, it's weaker. It's a weaker bond than the triple bond. Why? Because this is kind of basic knowledge where the triple bond is more stronger than the double bond. You can imagine how like 2 people is pulling a rope rather than 2 people is pulling the rope. That makes like 3 people is pulling 3 people is more stronger than 2 people, right? Normally. So which double bond is weaker than the triple bond? If a double bond is weaker, that means it's easier for it to donate the proton, So proton A, the hydrogen A, is more acidic than hydrogen E. So, whoops, wrong color. So we have this and this. Oh wait, no. Oh, it's this and this, right? Let me just see if this is correct. Okay, so weaker bond than the triple bond. Oh, it's not that. Okay, so I explained it wrong because it's the wrong example. So here, just rewind that. I can't even edit my own video. Probably too lazy, or I can try to edit it out, but it's probably weird. So what we have here is, since the double bond right here is like weaker, so the length of double bond will be like greater than the length of the triple bond, because triple bond pulls hydrogen closer. Wait, no. The triple bond has a shorter length than the double bond because it's stronger, so it has a shorter length. So in terms of length, the hydrogen A will be less acidic than hydrogen E. Yeah, because this is shorter. Whoops. Shorter. And this is longer. Okay? And yeah, because I just saw here it's A and E, and yeah. I was using that wrong because I got wrong here, so I kind of got confused by my explanation. But once I use the other explanation to explain the thing, it's more clear and I understand it more. So here is the end of my explanation video on real midterm of problem 3, acid and base. Hopefully these all make sense, and yeah, bye guys.